For decades, scientists searched for a second Earth, a rocky world with liquid water, the right temperature, and the right distance from its star. In 2015, they found one, Kepler 442b, a planet so similar to Earth that its habitability score was actually higher than our own. For a brief moment, it looked like the answer to one of humanity's oldest questions, but there was one devastating problem. Kepler 442b sits 1,206 light-years away. So far that no telescope on Earth or in orbit can analyze its atmosphere, confirm its surface conditions, or tell us anything beyond the fact that it exists. The most promising planet ever discovered was practically invisible. Then in 2022, scientists at the University of Montreal found something else, something closer, something stranger. A world that might be covered entirely in ocean, and for the first time in history, they had a telescope powerful enough to actually look. This is the story of why scientists are quietly walking away from the most Earth-like planet ever found and turning their attention to an ocean world that could change everything we know about life in the universe. It started with the numbers. In 2015, NASA's Kepler Space Telescope confirmed the existence of Kepler 442b, a planet orbiting a star in the constellation Lyra. It measured 1.34 times Earth's radius. It orbited its star every 112 days, placing it squarely in the habitable zone, that narrow band where liquid water could exist on a planet's surface. Scientists calculated its Earth similarity index at 0.836. For context, Earth's own score is lower. This planet, on paper, was more Earth-like than Earth itself. Headlines declared it one of the most habitable worlds ever found. Kepler 442b receives about two-thirds the sunlight Earth gets. Its star is cooler, older, and more stable than our Sun. Everything about it suggested conditions favorable for life, but the distance was a wall. At 1,206 light-years, even the James Webb Space Telescope cannot extract meaningful atmospheric data. Scientists could calculate its size, its orbit, its position in the habitable zone, but they could not study what actually matters. What is in the air? What is on the surface? Whether anything is alive. Kepler 442b became a beautiful question mark hanging in the dark, close enough to imagine, too far to answer. For the scientists who spent years studying it, the frustration was almost unbearable. They had found what looked like a second home, and they could not even peek through the window. Then Charles Cadieux changed the conversation. In 2022, Cadieux and his team at the University of Montreal announced a discovery using NASA's TESS satellite. They had confirmed the existence of TOI 1452b, a super-Earth orbiting a red dwarf star in the constellation Draco. It was not the most Earth-like planet ever found. It was something potentially more important. It was only 100 light-years away. Close enough to study. Close enough to analyze. Close enough for James Webb to read the chemical fingerprints of its atmosphere. And when the team examined its physical properties, they found something that did not match any rocky world ever cataloged. TOI 1452b is 1.67 times Earth's radius and nearly 5 times its mass. It whips around its star every 11 days. A year on this world lasts less than 2 Earth weeks. Its surface temperature hovers around 53 degrees Celsius, hot enough to be uncomfortable, but not hot enough to boil away an ocean. Those numbers alone were interesting. But the real puzzle was density. Earth has a bulk density of 5.5 grams per cubic centimeter. When Cadieux's team measured TOI 1452b, they found 5.6, nearly identical, despite the planet being almost 5 times more massive. That should not happen. Larger rocky planets compress under their own gravity and become denser. The numbers only worked if something lighter was adding mass without adding density, something like water, a lot of water. Modeling suggested water makes up between 9 and 52% of the planet's total mass. The best estimate settled around 22%. To understand what that means, consider this. Water makes up less than 1% of Earth's mass. TOI 1452b might contain hundreds of times more water than every ocean, river, lake, and glacier on our planet combined. If the models are correct, this is not a rocky world with oceans on top. This is a water world, a planet where the ocean is not a feature of the surface, it is the planet. Now imagine what such a world would look like. From space, TOI 1452b would look nothing like Earth. No continents, no green, no polar ice caps. Just a pale blue-gray sphere wrapped in cloud and vapor, glowing faintly in the reddish light of its star. An entire world of water stretching in every direction with no land in sight. No mountains breaking the surface, no coastlines, just water meeting sky meeting water again on the other side. TOI 145. 2b is different. It is not the most Earth-like planet. It is not the highest habitability score. It is something more important. It is knowable, observable, testable, and in science, observable beats theoretical every time. Now imagine the moment. JWST data comes back from another transit of TOI 1452b. Scientists process the spectra. Water vapor, confirmed. Hydrogen envelope, present. Then something else appears in the data, a chemical signature that should not be there, a molecule that only makes sense if something in that ocean is producing it. The room goes quiet. Someone rechecks the calibration, runs it again. The signal holds. That moment might come this year, next year, or it might take a decade of patient observation. But the tools exist, the target is in range, and the search is happening right now. If JWST finds biosignatures on TOI 1452b, it will not simply be a scientific discovery, it will be a philosophical earthquake. Every assumption about human uniqueness, rewritten by one line of atmospheric data from an ocean world no human will ever visit. Every religion, every philosophy, every quiet, late-night thought about whether we are truly alone, suddenly answered not by faith or speculation, but by data. That is the weight of what is being searched for right now, in light streaming from a telescope floating 1,000,000 miles from Earth, pointed at a pale world orbiting a red star in the constellation of the Dragon. Kepler 442b gave scientists a dream. TOI 1452b gives them a chance, and for the first time in human history, the oldest question we have ever asked, are we alone, has a telescope pointed at a possible answer. If this changed how you see the universe, subscribe. We cover the science rewriting what it means to exist. Now tell me, do you think JWST will find signs of life on TOI 1452b? Drop your answer below.